Hi, this is David Glenn. I'm the service manager for Precision Air Company. I want to put together a little bit of a training video regarding thermostat wiring and wiring terminal connections and making sure that we're doing it to industry standard and that we're all on the same page with how it should be done properly. Our objectives today is one, going over the color coding of the wiring and making sure that we're doing it to the industry standard. How to do proper wire nut connections when you're putting wires together with the thermostat wiring. Proper terminals and insulated and non-insulated crimping. Preparing your transformer for installation so that we can protect it. How to properly strip the wires or do wire inspections and when we should be correcting that. We also want to go over extending the thermostat harnesses because we've seen some issues in the field regarding this also. And how to secure your thermostat wiring harnesses or to start securing and organizing the wires in the furnace or air handlers. Okay, let's start with industry standard colors. First off, the HVAC industry has general standards that are pretty typical across the board. There are times when you can't use the colors that are expected. Whenever you're opening up a thermostat and they have bad wires to work with, they don't have enough conductors, you got to use with what you got. If there's any conductors that are not working anymore, they're broken somewhere in line and we are not changing out the entire harness or running a new thermostat wire to the thermostat or equipment. If you're tying into older non-standard harnesses, or in this case, on occasion we have a two-wire setup that we are only seeing a red and a white wire, but we're going to put in a heat pump or a gas furnace with air conditioner. So we're no longer doing just a heating call, we are now doing a cooling call. When that's the case, we may be using a wireless thermostat. So color coordination is not as critical under those conditions. You use what you can at the thermostat. However, for all other connections, it definitely applies. All right, start with the red wire. Red wire is your 24 volts, generally coming from the transformer, and it will always be placed on the R terminal. Now that could be RC, which is your cooling relay, or RH for your heating relay. It's very uncommon for us to put it on the RH unless you are in fact putting in only a gas furnace with a very dumbed down thermostat. For the most part, whether or not it's going to use the cooling or heating relay is dictated by the programming of the thermostat. For the most part, you're also going to find that they are jumpered together. So it's the same power coming in. Red goes on the R terminal. Yellow is your compressor call. Now, whether it's heating or cooling, or a heat pump, or an air conditioner, you put the yellow wire on the Y terminal. We're not using other colors. If yellow is available, it goes on the Y terminal. On heat pumps, it brings on heating. And we're going to kind of talk about that in a little bit. But you do not need to put a wire on W for a heating call with heat pumps. You only need the wire on Y to bring on the compressor and the outdoor unit. Heating is dictated by the OB contact. In most brands, the reversing valve is energized for cooling. So when it's not energized, it's naturally in the heating state. Rheem is not like that. Rheem is naturally in the cooling position with the reversing valve. And in order to bring on heating, you have to energize the B contact. Now, most thermostats, O and B, are the same terminal contact. And we'll talk about which wire that is at the end of this, well, throughout the slide here. There's a slide specifically covering that. But as for coloring of wiring, yellow wire goes on Y. The green wire is for your fan call. The green wire goes on the G terminal. Now, The G terminal is not actually energized when you use heating or cooling for the most part. It may be, but it's all programmed from the thermostat. For the most part, the air handler or the furnace control board manages when the fan should or should not be getting power. Blue wire. This is your common wire. If you have a blue wire and you need to have a common, you use the blue wire. At the thermostat, the wiring going from the thermostat to the air handler, from the air handler to the outdoor unit. If it's common, you use the blue wire. Now, the color of the wire inside the equipment, inside the air handler, the furnace, the heat pump, or air conditioner, makes no difference. We don't care if it's brown inside of a ream unit or if it's a different color. Whatever color the wire is inside the equipment, you tie it into a blue wire on the thermostat wire when blue is available. That is an industry standard. At the contact, you're going to be tying into the C terminal. C stands for common. The white wire. So as it says in the slide here, it can be a bit tricky. If it's a gas furnace, you're going to put the white wire on W. That's for the heating call. However, if it's a heat pump and there is a W terminal on the thermostat, do not put the white wire on W for heating for the compressor, period. You also don't want to use W1, W2, E, or auxiliary. If you're trying to wire up electric heat, that is when you want to apply the white wire, but you have to make sure that you have it wired up in coordination with the wires at the air handler and the heat pump. The heat pump in defrost mode will send a signal back to the air handler calling for electric heat. This has to be worked together. So W on the thermostat for a gas furnace is the heating call. Use the white wire there. If you are on a multi-staged heat pump, Y1 and Y2, or if there's a Y3 by chance, that is going to be the multi-stages needed for the compressor call for heating, managed by the OB wire terminal, and that would be your orange wire on the OB terminal. But the electric heat might have multiple stages. If it's a 20 kW, it may have a 10 kW stage 1 and a 10 kW stage 2. More often than not, you are going to wire to the E terminal on particularly a Honeywell T6, as that's the most common thermostat we're putting in. E or aux is going to be often what's used. If you use W1, W2, when it comes back to the air handler, you have to ensure that you are not wiring it to the heat pump itself. You're looking at the schematics for the specific wires for the heat sequencers. And we'll cover that more in a separate video on the Precision Air Company YouTube channel for multi-staged heating. As for your white wire, if it's left unused, a lot of companies, if you're on train equipment for service technicians, you might see that a black wire is used for emergency heat. A lot of the times, that's the wire they like to use for that. But the white wire can be used for emergency heat. It just doesn't go on the W terminal. You don't want to put it on W1, W2 on a Honeywell T6 or most Honeywell thermostats. You have to look at the schematics particular to that thermostat on how it gets wired. But the wiring back at the air handler is fairly consistent. Whatever wire you're using for emergency heat, if it's multi-stage, you may have to jump them together. You can have E going to your first stage of electric heat, and then use W2 for the second stage of electric heat. But again, we'll cover that more in another video. Orange wire, like I stated, that doesn't matter if it is going to be energized on O or if it's going to be energized on B. Use the orange wire to control the reversing valve. That is what you use the orange wire for, to control the reversing valve. There's other colors that might be in there, anywhere from pink, purple, violet, striped colors. It depends on the thermostat connections you're going to be at. But when you're tying into older thermostats, somebody may have put in a harness that has a significantly wider variety of colors available. But for the most part, those can be used for sensors or if you have multi-stages and things like that. But your primary colors we need to be putting on the HVAC industry standard terminals that were just discussed. Moving on. Proper wire nut connections. All right. When you are wiring up the air handler wiring to the thermostat wires or the heat pump to the thermostat wiring, and you're using wire nuts, you need to be doing it correctly because we're having too many wires that are popping out. One, get all of your wires together and then put the wire nut on there with about a 1/2 inch to 3/4 of an inch worth of conductor. You don't need to necessarily pre-twist this. If you hold all of the wires together and press them into the wire nut and then twist it, it will grab all of the wires. If you have a hard time fitting all of the wires into the wire nut, get a bigger wire nut. But when you do twist it, look at the picture here. You can see how it's twisted across the wiring itself. You're actually going to want to go about a minimum of 1 inch where the thermostat wiring is twisting around. This is so that it cannot pull out. It grabs it and it holds it, and you're braiding it down. If you're not doing this, wires are going to too easily pop out of the wire nuts. They're not entirely grabbed in. This holds them together. Even if the wire nut fails, this is going to hold those wires together. Whether you're on service calls, if we're going out on a diagnostic and we're troubleshooting wiring issues, this is another thing to look for. But when you are doing installations or just tune-ups, you need to be inspecting wiring. If you're coming across the insulation is nicked, sliced, or in this case, as in this picture, was from a recent installation callback where we tied into the old thermostat wiring with new thermostat wiring. The old thermostat wiring, most of the conductors looked, as you see in this picture, where it's cracked. This has got to be cut back, and not just a little bit of the wire. You cut back the whole harness and use a new section. Take the sheath off, and restrip your wires. You also need to try to keep all your wires fairly uniform so you're not having long leads sticking out everywhere. But you cut away the damaged section. You need to inspect the wiring. This is a very common cause of low voltage shorts and issues in the system, or intermittent problems in the system. And when the conductor itself, while it may seem okay and it may work sometimes, you could potentially have a busted solid conductor inside the insulation of that particular wire. Now, voltage, when you're reading out for voltage, you may have 24 volts reading across the contacts. Now, voltage will read good if you have just 1 atom of contact of copper in the wire. But if it's cracked and busted and it's just barely touching, you will read good voltage across that little bit of touching. But what you won't get is the system to operate properly, because current can't pass through that. You need more than just the minimal contact. You need the full conductor to properly transfer current through the system. So reading out for voltage is not always going to give you the answer as to whether or not the wire is good. You need to inspect it. A lot of the times during the removal of the sheath around the harness, you end up damaging the wire, or you nick it and cut it. But if you're finding these problems, you need to repair it. All right, I'm seeing this a lot. Wires that aren't used, they're twisted around the harness. Nothing wrong with that as long as they're all done nicely and neatly. What I don't want to see is the wires that are unused left around the harness with the conductor still showing at the end of it because it was stripped and used at one point. You need to cut that off, trim it back. Harnesses can touch, other wires can touch those undone conductors, and if there's ever a short inside the line, these become a real problem. And you don't want to have unused conductors just floating in the compartment, completely looking like a bunch of loose hairs on a toddler's head. These conductors, when you're troubleshooting or moving things around, they can fall into high voltage contacts. Now, if you ever have a low voltage wire that's tied into the system and it ends up touching high voltage, that can blow through gateway transistors, it can blow through diodes, and it will tear through control boards across the system. I've seen control boards and low voltage components throughout the system, from the thermostat to the furnace control board, a zone board, and then the outdoor units board, when a spare unused wire that was used, in this case it wasn't a spare unused wire, it was during troubleshooting, the wire came off, hit the low voltage, it just dropped, and it landed right on the contact for the high voltage, and it sent high voltage through the entire low voltage system and fried everything. So pay attention to that. When you're doing installs on service or whatever, you see these problems where you got these loose conductors floating around, take the time, get them cleaned up to protect the system, and so that we don't have unnecessary problems popping up. All right, crimping. I'm seeing a lot of people using plier flats, or using the sharp edge of wire cutters and things like that, or they're using the flat of a handle in order to crush the crimp barrel on terminals. The problem is it does a flat crimp, and it doesn't give the proper pinch to the conductor inside the barrel. So you should have proper pliers for crimping terminals, and it has a non, which is non-insulated, and an INS, which is insulated terminals. Two different ways of doing the crimps, and it matters because if it's insulated, it's not jabbing in as deep in the same manner as it would on a non-insulated one. It's crimping in such a way that it's going to crush the entire barrel on insulated ones. So you need to be doing that correctly. On non-insulated ones, I'm seeing where there is a large excess of wiring sticking out the front of the terminal, and I'm seeing excess wire sticking out the back. When you are crimping non-insulated terminals, or in this, if you're doing insulated, the insulation on the wire needs to actually get into the inside of the insulated terminal before you crimp. If you need to trim back your conductors, do so, but it needs to be crimped properly. Non-insulated wires, there's this tiny little tab inside past the barrel that is designed to be the stop point for the conductors. If your conductor is too long, trim it. Because on the back side of the terminal, the wire insulation needs to be butted up to the edge of the barrel. You shouldn't have any excess. It's a very small zone. Also, when you're crimping a non-insulated barrel, you got to use the non-insulated portion of the crimpers. And there's a seam on that metal barrel. That metal barrel has to be in the cup. As you see in this picture, there's a tiny little seam, and it's actually in the cup section of the crimpers. If you flip it around and crimp it, all it does is spread the barrel open, and it doesn't really crimp the wires properly. If the seam is in the cup and away from the crimper itself, then it's going to crush the crimp around the conductors and hold it properly in place. All right, protecting transformers. We've been doing a lot of transformer installs for zone boards, or if you're doing the Red Link wireless thermostat, you need to be able to power the Red Link EIM board with a secondary transformer. Now, when you're wiring the transformers together or putting the new transformer in, you just need to wire it in parallel. If it's a 120 volt system, look at the two wires for the system's transformer that's already in there. All you have to do is take those wires off of where they're going, cut off the terminals because they probably go to a control board or something. Get two additional wires, and black to black, white to white, with an excess wire going back to the control board. All you're doing is putting the secondary transformer on the same power wires coming from the boards of the transformer. The unused wires, you can trim them back if they're not going to be used. That's fine. However, they need to be crimped. Don't cut back all of the wire to the point where you have no room to crimp on terminal caps. If you're using wire nuts in this case, that's acceptable. You have to have a stripped back section of the conductor showing before you put on the wire nut. Don't put a wire nut on over the insulation. But what you do not do is just snip the wires and leave them there. There is still the flat edge of that cut wire still has a little bit of conductor showing, and if for any reason those wires go errant and they end up touching ground, you can destroy the transformer. Anytime you put in a new transformer, you need to protect it if it doesn't have a built-in fuse or a resettable fuse. You must protect it on the low voltage side. So in this case, the transformer has a red and a green wire, which is the 24 volt section. It doesn't matter which wire you're putting the fuse in line on. It's going to be in series. So in this case, I picked the green wire. You snip the existing green wire, crimp on a terminal, add a fuse to one end, and your wire comes out the end, and you wire it into your low voltage system. By doing this, if there's any low voltage shorts downline, you're not frying out the transformer in the event of a low voltage short. So you must fuse the transformer. They're a lot more expensive, and the fuses are incredibly cheap. So there's no reason not to do this. All right, and connecting wires and stripping wires. Okay, so when you're removing the harness sheath around a thermostat harness to get to the conductors, you need to do a lengthwise incision on the thermostat wires, and that's not guaranteed. If you're doing it with a razor, it's not guaranteed to prevent you from nicking a wire, but it is a lot more likely that you will not. Do not go circular around the sheath. When you do that, you are not going to avoid slicing the inner conductor on some of the wires that are inside that sheath. If you make these tiny little incisions at the base, you're creating a break point, you're creating a short point. And so you must start doing lengthwise incisions. I'm trying to find the right words here. If the wiring has nicks, slices, or anything like that, you need cut off the whole section. Okay, don't do it where only this wire is exposed. I'll leave the other one super long, and then I'll have this one short thermostat wire that I had to pull out of the system. Cut the whole harness and redo all the wires. They should all be uniform in length. You shouldn't have these long stragglers. It causes problems because now you've got this one extra conductor that you're trying to fold and cram to get out of the way, and that actually leads to problems with that thermostat wire. Potentially breaking or damaging that insulation. When you are doing your terminal connections, now this doesn't matter if you're doing it at the thermostat or any other device such as a zone board or an EIM board, if it has a pin tab insulation or an insertion point for connection, you cannot have it like you see in this picture with the conductors sticking out as they are. You need to trim the conductor so that it does two things. One, it's still able to fully insert. And usually you just strip the end of the wire, stick it in the hole. If there is an excess of conductor sticking out of the terminal hole, you pull it back out and you trim off that amount and you reinsert it. If you did not make the strip section long enough so that the conductor is able to fully insert itself all the way into the terminal, then you need to redo it. Strip off a little bit further, put it in, and then trim it and then set it. If you have unused conductors that are in here, you need to tuck them back in such a way that they are not going to interfere with anything else. But more importantly, put your wires on the correct terminals with the correct wiring colors, and get us on the same page as everybody else in the industry. Okay, we don't need to be the weird oddballs that don't know how to wire up thermostats and whatnot. All right, so a lot of the times we need to take a harness that's existing and tie into it because we're not, for whatever reason, running a new thermostat harness to the outside or to the inside. That's acceptable as long as it's done right. One, don't just have this mess of snarled, kinked, old, busted wires. Trim the harness back. Don't tie into the old connections. The picture that I showed where the wiring was cracked on a lot of the insulation, and that's an example of where we did that. You snip the entire harness back, de-sheath it going back without doing a circular cut on the harness insulation sheath, but you do a lengthwise cut. When you are joining the wires, all of the wires must be connected. Okay, if there is a 5-wire harness and you are extending it with a new 5-wire harness and you only need 2 wires outside, you still connect all 5 wires, and they should be color matched, blue to blue, yellow to yellow, red to red. Don't just take the wires that you need to connect and then leave all of the others disconnected. Don't ever do that. Sometimes wires get damaged. We need to use the other harness, and you're just creating a bigger problem that some technician's going to be fighting down the road. When you use the wire nuts, each of the connections need to have at least an inch of braided and twist. Not a loose braid where it just went around a couple of times. It should be a tight braid of at least an inch beyond the wire nut itself. Keeping things neat. This picture is showing you zip ties. Okay, you should have little bags of varying sizes in the vans. Okay, not just giant ones, which are useful. You need some big ones for the larger jobs, especially if you're trying to clean up I don't know, line sets and stuff like that, trying to keep things in place. However, for thermostat wiring, you have to have the excess harness. That is necessary. You want to have some extra in there, but you don't need 2 to 3 feet of extra wiring harness inside the air handler. Trim it back. It's completely unnecessary to have that much wire in there. Have an appropriate amount. A lot of times people will twist it around a screwdriver to create something of a phone cord look. So the excess is not just this obnoxious harness that's hanging out inside the compartment. Most of the time you see that at units outside where they did the accordion look to it. So inside the actual compartment, you should be trying to clean up the wires. Don't leave a giant spaghetti ball of wires inside the harness. Clean it up. Get some zip ties out. Make wires into bundles. And try to be smart about how you do the bundles. You know, these wires are going to be coming off in one section if somebody has to remove it, and these wires are just going to be on this particular harness. But either way, you want the wiring organized in such a manner that it is easy to follow things out. It is meant to keep things out of the way so excess wires aren't getting snagged. Make it look nice. Take pride in the appearance of our work. when technicians or other companies have to come out to our equipment and they open it up. You've done it yourself. You've opened up something somebody else has worked on, and you're wondering, how did they have this job? Make it look nice. Take pride in the appearance of the work. There will be other training videos that I'll put together as needed, but for right now, this is what we've got. There's going to be a second video that I recommend watching or get on YouTube for other ideas when it comes to troubleshooting or how to wire up heat pumps in various means and configurations. But for the most part, I want everybody on the same page for how to wire up and connect thermostat wiring. Thank you.